Hello, everyone. Welcome to Industrial Transformation Summit. With me, I have a special guest, Robert Feldman from Microsoft. Robert, could you shortly introduce yourself and what is your role at Microsoft?
Yeah, thanks, Lucas, for having me here. My name is Robert Feldman. I'm industry advisor at Microsoft based in Frankfurt. What does an industry advisor do? Well, we're kind of the guys, they go-between guys between what a customer real needs and what are the products they actually sourcing. But this is often not so clear in the beginning. So our role is, we call this pre-sales, so early on explore and find out the needs, and it's all around Azure. And in my case, it's all around plants, labs, and engineering. So I'm a guy with the difficult stuff, right, in plants, not in the offices. That's where I mostly focus on.
I understand that it's about really manufacturing and discrete process. What are the biggest differences between those two industries?
Yeah, it's interesting that you say that, because Industrial Transformation Summit that we're on today is split in 2 days indeed. So today is discrete day and tomorrow is process industry days. I think one thing that's maybe easy to understand, discrete is about assembling stuff. So assembling a car out of 3,000-4,000 pieces, right? And then of course you have to make that work. So that's or a cell phone or something else, right? But if you look in processes, it's about powders and liquids. That's easy to remember. So if you a washing powder for washing a laundry, that's a powder. It's a chemical product. Any liquid, an acid or something, right? And of course, pumping liquid through pipes and powder. That's a totally different process, right? Also, process industry tend to run 24/7, so round the clock. They basically never stop. Very similar to a power station, by the way. Power station for electricity are also process industries, right? And discrete, you have shifts, right? You have a morning shift, you have a night shift. You also have shifts in process, but you have a shift that you can just build stuff in the morning and then shut it up during the night and start in the morning again. That's not an option in process industry. They run all the time.
Obviously, there is a different impact of the downtime. Okay.
Yes, indeed. Downtimes are really, really expensive in process industries. And so you just have to keep these things running all the time, indeed.
Very, very challenging. So right now we are in the very, let's say, challenging situation for the manufacturing itself. On the one side, the economic growth is not progressing as expected. On the other side, there are some regulations present only in the European Union, and which means increased costs. Also, the energy costs are quite high. Do you think that, let's say, Microsoft can support customers in their journey in such a challenging times?
Yeah, sure. So I think, and that's what we've been doing for quite a while. I think maybe many people are not aware how deeply entrenched and how deeply we are already supporting in the process industries. Process industry, number one, they are data rich, and they have been data rich. They have been recording thousands of data points for decades already. So they had they call these things historians. A historian is a database that stores, by the way, a black box in a plane. When a plane crashes, the first thing is they get the black box. The black box is a data logger. It has all the data recorded, and they find out, okay, the plane crashed because a sensor XYZ was broken, right? And the same in a chemical plants. Chemical plants also tended to have exploded in the earlier days. Think of the big catastrophes, Seveso and all those big accidents. So by law, they have to have these black boxes. We call them historians. So they are super data rich. Plus, if you go to a chemical plant, they are already highly automated. They have everything remote controlled via telemetry. They have control rooms, but this is where you basically drive the chemical plant, and the driver may be 2 kilometers away from the physical location. So they're very, very, very advanced. Plus, they have to have additional security mechanisms, right? Everything has to be double redundant and so on and so on. So much more higher level of sophistication historically than, let's say, discrete industries, right? And so what can we do there? Well, we can mine those data and build sophisticated models, which has been done around that. And we can help them improve on 4 categories, and they typically call them process industries: yield, energy, throughput, and quality. YETQ. That's the acronym for process industry. Improving yield means you want more of the higher quality, which you can sell more expensive, versus the lower grade quality, which you cannot sell so expensive, you have to sell at a discount. So if you get more grade A quality product, that helps. So algorithms can help improve the output in grade A quality. Then energy, that's a big one, you mentioned that. Energy costs tend to fluctuate. It's like you are burning something, right? And when you burn, you can't control it that well, so you have a lot of stochastic fluctuations. The gas quality is different and everything. So there are other algorithms that can help real-time optimization for energy. Throughput is important when you're sold out. Well, wouldn't it be great if you could sell a bit more, because you can sell everything at a high profit? Not the current problem for many chemical industries, but there are some sections of the chemical plants that are sold out where they cannot produce enough. So there, if you can increase throughput, which means instead of 1,000 tons per hour, you get 1,020 tons per hour, that's 20 tons extra, you can sell at a high profit. And the quality per se, quality is defined differently per each product, but quality is typically a KPI that you measure in laboratories. You define some quality standards, KPIs, and you can also help to optimize. In the summary, the problem in the process industry is because it runs continuously. It's about fluctuations, stochastic volatility fluctuations. Those you can predict with data-rich models. The data are there. We can leverage those, and we can do great things. The only problem is, so far, these models have been super expensive. They have been very sophisticated people working them, but now we want to repeat them and scale them out, because it's no good if the model runs on one plant or on one part of a plant as a pilot, but you want it to run 100 times. And this is the challenge we're entering now. How can we massify those things? We know they work.
Yes, so I can imagine that it's not easy to change the process, because those processes exist for many years, right? If you look in the metal industry, the electrolysis used to create the high quality of let's say of cuprum or nickel, right? Those processes exist for years, and it's very difficult to change the process itself, because the people trust the existing process, and then when you are trying to optimize, maybe change the formulation, maybe to reduce the dependence on the different ingredients, then it creates a tension in the company. So how do you see adoption of the novel techniques, novel approaches to the existing processes and in those traditional chemical business?
Yeah, so automation is not a new thing, right? So when we talk now about introducing AI and models, or in the end closed loop autonomously running models, the people are used to automation, right? Thanks to Siemens, Honeywell, our partners, Rockwell, and those companies, they have done fantastic jobs in doing that. That's one thing. So yes, but they're used to innovation. The second part, we've had like advanced process controls coming up already in the 90s. Advanced process controls is also sophisticated software running typically on Windows and PCs. Which is rules-based. So we've had if temperature greater than 5, then adjust the setting to XYZ. Those have been around, and those are in places. Now with AI, we introduce another layer of complexity and sophistication, right? The AI is much better. Still, it gets typically, I've done these projects myself in my prior life, you can get 3 to 8, 10 or more % extra out just with AI, even on top of advanced process controls. So yes, the people may be skeptical, but the matter is, let it run side by side. You can run these models in open loop or closed loop. Mm-hmm. Open loop means, it calculates something and it shows it on a screen. And then the driver or the operator of that machine can say, I like this recommendation, I'll try it out and see what it does. Well, she will try it out. And then something happens, and if the operator, the expert says, look, it was a good advice, seems to do the job, after a while they start trusting it. And in the projects where I've been involved in my prior life at a large consulting company, there it took no longer than 3 months until people really trusted the thing, and then they even ask, can you put this in automated mode? Because I don't want to do all the mouse clicks anymore. I have enough mouse clicks to do anyway the way it is. Can this thing not run by its own? And only if there's something extraordinary, then basically give it back to me. Basically the same as a pilot on a plane does. I mean, we've had autopilots on planes for a long time. This is like the autopilot for chemical equipment, no difference.
Several times you have mentioned new models, new AI technologies. When you look at the process inside the plant, which let's say aspects of those processes can be really, let's say, optimized, augmented with AI? Where is the low-hanging fruit?
So it's interesting that you say that. So we've had the cloud more or less since 2010, so for around 15 years, right? We started with IoT about that time as well. 2011, I think Hannover Messe was the big kickoff of Industry 4.0. So we've gained some experiences, and then machine learning started like around 2015, 16. So we've almost had 10 years of machine learning. That was the low-hanging fruit in a way, but low-hanging to the degree that advanced mathematics, advanced analytics were applied, and now we know it works. The high part is now to scale it and make it repeatable, and the high part is also what I call model lifecycle management, because a model has model drift, it ages, the equipment ages, right? It was trained on equipment 2 years ago, now it's 2 years older. Everybody that drives a used car knows that the used car is not the same 2 years later than before. The same happens with equipment. So that's one part. What is now exciting with the GenAI part is, let's put it, I call it, there's AI for machines and there's AI for humans. It's very simple. In plants, it's about man and machine, the typical man-machine combination, right? I call the ML, that's the AI for machines, because AM is basically mathematics. It talks mathematical language, right? And code and machine code, right? That's basically the ML part. Now, with ChatGPT and LLMs and those models, we have the capability to process language, human language, and images and pictures. And that adds a new dimension. So when you now go into process plant, you have the machines there. Now, where are the humans? Well, in the control room, there's only 2 humans there. There's, you can help them somewhat, but it's highly automated. There's some things that will help them. But we do have lots of humans still in the maintenance, in the whole asset management, asset integrity, asset whatever it's called, performance management area. We have humans that need to go out to repair jobs. We have external contractors. A lot of companies have outsourced this to contractors already, right? So this is the opportunity. Now we can understand, we can upload the manuals, we can upload technical drawings. If we have them on paper, we can get OCR them first and then make them accessible. We have drones that fly over, produce videos. We have additional sensors that produce information. We have now fragmented, distributed information. With GenAI, and thanks to the Microsoft Technology Fabric, the integrated unified data layer, thanks to the tools that are out there, and thanks to the partners that now produce all these highly specialized solutions, we can now mine the unstructured information, as we call it. We've mined the historian data, yes, but we're now mining the rest. And then we can get a much more comprehensive picture, and we can do root cause failure analysis.
So I understand that, Jan, I understand that the foundational to training any AI model is the data layer.
Yes.
So the data availability, but also data with different modality, visuals, text, sensors data.
Yes.
How do you think the companies are understanding this let's say requirement to bring all the data together? Usually, I'm asking because usually OT is separate from IT. There are different teams, different places, and what is your key message to such teams that don't fully embrace this requirement about the data?
So I think you're basically talking about how can we progress this and how can we make it scalable, right? Because historically, in particularly in process industries, people have been used to buying systems, right? I buy a system. I buy basically they've put out tenders. Then they went shopping, and then they decided on one basically system. And the system was typically built around the database, right? If you buy a manufacturing execution system, right, software system, you basically get the software installed, and it does the PC in the plant. And then it runs there. It's visible on screens, and you can do stuff with. This is like old school. This is the past. So we have basically now, as you rightfully say, then we have different owners of these different systems in different departments. I think you can classify in process industry 3 areas. One area is the automation and instrumentation area, where the control systems, which basically switch equipment on and off and control the equipments, are sitting. There's the PERDO model, the ISO 95 pyramid, where you have the field level, the control level. You then have, and they are up to the MAS and the ERP level. That's the world that the OT trained engineers are used to, right? Totally different from the IT world. On the other side, you have the classical office-based IT, typically, ERP, SAP, you have, which has just migrated from traditional, basically also software built around the database. In that sense, the OT and the IT world are the same, because you have, funny enough, you have Windows PCs in the plants, and you have Windows PCs in the offices, right? Except different software running on it. And then you have the separate hardware for the automation control, which is a different one. So I would say there's the IT for office. There's what they now call IT for OT, which is the IT software systems that run on traditional IT infrastructure, except in the plants or in the laboratories. A lot of companies have now, to your IT-OT convergence is really the subject, the way I understand it, because IT-OT convergence is now happening because they're setting up inside IT people that do deal with the IT for OT. And the automation guys and the IT for OT guys now get closer together. That is one way of converging it. Physically, they've tried for a long time to physically interconnect systems. So there's all these efforts with, the protocols, OPC, DA, OPC, UA, and so on. Yes, these efforts continue, but honestly, they don't work super well, because there's also interest in the vendors to install certain complications, let's call it, that it doesn't work as freely as everybody needs it. So Microsoft, of course, is very much enforcing open standards and introducing them. But I think where we're seeing the IT-OT convergence, to your topic, is indeed on the data layer. We're not going to see it in the physical layer, connecting everything together with cables. That was like old school thinking. The new thinking, and this is basically triggered also by the recent Gen AI adoption, is basically saying, well, look, we use a lakehouse. The lakehouse basically is good for unstructured data, good for structured data. It can deal with any kind of data, and the only lakehouse job, I call this, is the equivalent to the sewage in a city. A city would not work if we would not have sewers, electric cable, telecommunications cable, gas pipes, water pipes under the ground. Your house would be worthless, or nearly worthless, or not as comfortable for sure, if we didn't have that. So we tend to ignore that. So we need this kind of underground, I call it underground infrastructure, and that's the data preparation, provisioning, contextualization, and all of that. That is a massive job, and I would say basically the Microsoft Fabric product is probably, for me, it's the most groundbreaking breakthrough invention of mankind, honestly, because without that, we'd be dead. Imagine in the Middle Ages in Europe, we had sophisticated cities, but they were pouring everything out in the street, right? Right? Imagine, right? So only we became really civilized in the 19th century when we started building this sewage system, and since then, diseases have gone by and so on. Well, a bit like that, we had diseases with data, you could say, right? Literally, take that example. And now, because we have a sophisticated water management, sewage management, and transmission management infrastructure, which is Fabric, now we are able to go to a civilized state of running advanced applications. And I dare say, it's not, to me, it's not AI or not. I'm saying we are moving into a new era of software, advanced software, because we're going to have software that has no AI at all, because rules are still working. When 1 + 1 is 2, you don't need to predict with a
works,
probability of 93% that 1 + 1 is probably 2. So mathematics still work. Physics equations still work. Rules still work because rules have served us well. They still work. And on top of that, now you get the reasoning. So we're going to have software where we're going to have 0% AI. We are going to software with 17% AI in its functionality, maybe some with 83% AI. These sophisticated software products are being built right now, and they are possible because the data is now finally available. Because these, think of it, they're like a Formula One engine. We just had the Abu Dhabi finale, right, on Formula One. Well, these are ultra sophisticated engines, and if the fuel is not good, they stutter, they don't perform. So the same with a highly sophisticated piece of software. If the fuel, the data is not perfectly on time, perfectly like it can't do its job. So we need this infrastructure and we need the powerful solutions, and we're going to see, and this is part of this transformation summit, where we're seeing exceptional deployments of solutions already, but there's just a glimpse of what's yet to come.
So let's assume that we already have a data layer with all those different modalities of data available. Where would you start the applications of artificial intelligence and agentic AI to bring the most impact specifically in the process industry?
So I would say in the control rooms, it's about now making them more robust, and lifecycle management. A lot of these solutions exist already. They just need to be professionalized. That I think is a continuous. Where there's real disruption is in the coming back to the maintenance asset performance area, where there's still lots of humans there, right? You have humans of different levels. You have. I'll give you some examples. I was with a big steel manufacturer just 2 weeks ago. Not in Germany, in the Middle East. And there the issue is they have workers from India. India has 46, I think, languages. So even if there's 2 Indians there, they might not even understand each other. Not everybody's perfectly fluent in English. They have Indians, Arabs, and so on. So we said one issue is multilinguality problems. Resolve the multilinguality problem. They had a tragic accident a few years ago, which they thought was due to the worker not fully really understanding what they were supposed to do, misunderstanding in language and all of that. It caused the accident. We want to avoid that at all costs. So they have a big driver and saying, now, if the technology is so far that you can speak in your natural language, it auto-translates it, or it then does the protocol. For example, your maintenance work, you go to a machine, you make a photo, you talk in a mic. We now have noise cancelling technology. That's perfectly well. You speak to a mic and say, look, this is what I found. This is what I did. This is the picture of it. Please write the maintenance report. This worker speaks in his natural language, in Hindi or whatever. The report is in English because that's the language of record, fully automatic transposed. He can say, well, send it to my mobile. I'll make a quick check. Yeah, it's fine. I press the button, okay for me, and then it's published instantly without them having to walk back. Often you have to walk back 1 kilometer or more until you're back to your PC at the desk. And they have, protective wear. It's not so great to punch on a piece of glass with protective gloves that are maybe oily and greasy, and all of you can imagine. So this is a real breakthrough that you can use in natural language. You can use the multilingual capability. That's one example. Another example is the skilling problem, right? We have it everywhere, but in the process industry, of course, as well. It takes you up to 15 or more years to be a real good driver of a chemical plant, meaning the operator of that plant. They have a training, they have an apprenticeship model where they get trained to learn to do the things. What if we could train up the new operators much faster with AI assistance, giving tips? The example I use is the car. Do you know what Uber is to me? Uber is to me a global huge brain for 200,000 plus drivers. The only requirement with Uber is a valid driver license. That's it. You don't need to know any roads. You don't need to collect money. You don't need, all you do is, I'm ready, the system tells you where to go, where to pick up the passengers, where to drop them off, and all of that. Wonderful. It's one giant brain, right? It's basically managing 200,000 people. Imagine you are a maintenance worker, you arrive in the morning, at your morning shift. There's like an Uber-like or an GPS-like. The car navigation system, by the way, is also AI. We've had AI in the car for 20 years. We just call it navigation system or sat-nav. But it is AI because it thinks for you. You just tell it where you want to go. It selects among various different routes. It suggests the best route to destination. When you ignore it, it immediately recalculates without you having to punch anything in. And if there's a traffic jam, it says, look, I found an alternative route for you. So you have your brain in the car for the traffic, the helper. Well, wouldn't it be wonderful, your maintenance worker, you have something like the car equivalent or the other example equivalent that guides you through your day. Things change during the day. Well, what if the assistant says, look, hey, I don't need you to go there. Why don't you go there? Because it's more urgent that you fix that one first. By the way, I've already asked for the milk run. The milk run, they will bring you the spare parts. And all you have to do, install them. And by the way, this is how you do it. I think that people would also be much more happy. We are happy as drivers, aren't we? We are so used to navigation systems. I want the same comfort in plants.
Mm-hmm. Yes, that reminds me our discussion with Andritz. They say that the operators in the power plants, they don't want 30 screens with all those different levels of different sensors data. They just want to have a blank screen, and if something goes wrong, there is a message popping up. Hey, pay attention. So maybe that's the new future for the power plants.
Yeah, look, there's one movie that has impressed me a lot when I was younger, Stanley Kubrick's Space Odyssey 2010.
Yes.
You know, what's so particular about that movie? You don't see, it's a spaceship, right? And it's one guy on a spaceship, right? I might not recall it perfectly well. I just recall what stuck to my mind. It's basically one guy talking to a voice in an extremely complex machine, which is that spaceship. I didn't see 25 computer screens in a huge control room there. I just observed this person talking. That, of course, then the Hollywood style, that it goes a bit crazy and so on, that's another story. But the principle is we are going to be able, and we are already able, with just voice command, control extremely complex machinery. So we don't need screens, you're completely right. If you want them, we can tell the voice, please show it to me on the screen, I want to see it, right? But we don't need it.
I would love to be implemented for everyone so that we don't need those screens in front of us every time we want to interact with people, that we can just interact just by spending time together.
Yes.
Yeah, but so I am with you. I think that we are, let's say, at the edge of the situation where we really, let's say, can reduce the amount of information being presented, that we can be more effective just by working with AI agents, right? Doing those tedious work for us. And with this, maybe let me come back to the last question. What would be the key message that you would like to leave the audience with, regardless if they are part of the process industry, but maybe some manufacturing in general? What would be the key message?
I think the key message is trial and error here, right? Just trying it out. I mean, I'm a different person, I have to say, since I started using Copilot, right? It's absolutely amazing, and I was skeptical at first as well, right? And you follow the mainstream, AI is dangerous for you and whatever. Yeah, that may all be true, but it's a simplification, because the reality is it's a practical tool. It's a tool. It makes life more comfortable and convenient, and it's bloody good. I mean, sorry for my English, but I mean, it's amazing. And I would say at work, just try it out. I mean, trial and error. I mean, try out, fail fast, try something else, fail fast, and then until something really sticks. I think this perfectionism that I'm hearing from often, I asked it a question, the question was not perfect. I think that's more the database research world we're used to, right? The traditional world for researching in a database, you had to be super specific. but then also you got super specific answers in return. That's true.
Yeah.
But a database query is very complex and very difficult. Now, look, now we don't have these hard efforts to enter something, even a typo or whatever was a disaster with a traditional database search. Now we can have a typo, we can whatever. It still understands us, right? So that part is easier. On the other side, it gets us back more or less what we would get back from another human, not from a precise database. So to think of it as a precise database is the wrong thinking. Think of it as basically a synthetic human, right? Yeah. And look, Lukasz, if I ask you, what year was Marie Antoinette born?
Probably I would ask Copilot to...
No, or you would say sometimes around 1700 something, right?
Yeah.
So you would not give an answer with 100% precision. So I think it's also not correct to expect 100% precision. What I do, I go and say, look, I think that was the wrong answer. Honestly, I think you're wrong. Mm-hmm. I tell the AI, I say, I think you're wrong. Mm-hmm. Then the AI comes back, oh, I guess you were right. Yeah, I looked it up another time. Maybe this answer is closer to the truth. So you need to challenge the thing, right? And at work, I think, for the coming back and closing off for the process industry, I think we need to separate out things in two ways. There's like the convenience element of AI. Get something not perfect, but quick enough and good enough. And I would say a lot of what we do in a typical day is good enough, is in most cases good enough. Okay. And where you need super precision. For the super precision, I think we need to build, and this is being built at the moment, we need to build, I call these AI reasoning engines, and then the AI reasoning engine also has to have validation mechanism. For example, in journalism, a good journalist only publishes things after they've cross-checked and validated the facts. That's good journalism, right? Unfortunately, we don't have so much of that, unfortunately, anymore, maybe, right? But good journalism works that way. Now, same in engineering. If you cannot trust the AI in first glimpse, you need to run loops, validation loops, and that's being built. For example, if the AI says, well, set the temperature at 87.3 degrees, well, you need to have a cross-validation loop checking back into manuals, into old records, maybe checking back with how has your other colleagues put the set point at the time. I said, look, I think this 87 is good, and here's why. I've checked it against this, and therefore you can trust it. I think this is what's getting built now at the moment, that we have this additional cross-validation, and that satisfies then the need for the people who need precision.
Yes, I agree that that comes back to the traceability, which means to trace where this answer is coming from.
Yes.
And this is part of Azure by design.
Yes. I would say Azure and Microsoft, we offer the tools, right, for this, but it's the partners of ours who are really perfecting it. For example, Andritz, Siemens, ABB, Aviva, all these companies, I think can trust them because it's their job.
Yep,
they have over decades always built very technical, special solutions, and Microsoft has provided over decades the technology. We've provided MS-DOS, Windows NT, Win Server, and now we're providing Azure, because Windows NT Server cannot process AI, but Azure can. So we're moving to a new generation of operating system, of technology to support this new AI world. And of course, our partners are now building their new generation of software on top of this new operating system, I may say so. Azure is really a global operating system, a platform that allows to do that. And that's where the symbiosis comes from. So if you demand from Microsoft this super deep technical solution, we will always point you to our partner network, who are the deep experts on that, and particularly on these highly important technical questions. They are now building these robust versions of AI, but it's not AI. It's advanced software which has some AI capabilities built in. But of course, we'll still use traditional mathematics, physical equations, and rules as well, right? This is what's getting built. That's advanced software.
That's a great message that we should really be collaborating together with partners to bring the best of the best to the customers and to really, let's say, transform their business towards the, let's say, very important goals. So thank you very much, Robert. It was a good discussion.
Thank you very much.
Thank you, everyone, for listening to us, spending time with us as a part of Industrial Transformation Summit.